Saxon Algebra 2. Lesson, this is a lie. It's not 87, it's 88. 2 topics. John, how could you? The first one is the distance formula. This is kind of fun and kind of cool. This is a really difficult looking formula that comes from a really logical place. So even though it's gonna look a little scary, I want you to not be afraid of it. Promise me right now that you will not let it psych you out. Okay, I assume you promised. Here's an old friend. Pythagorean Theorem. Sorry, I can't even write it. We know that if you have a right triangle and you call the legs A and B, doesn't matter which is which, but you call the hypotenuse C, we can write this nifty equation, right? And it's really great because no matter which of these pieces you have, as long as you have 2, you can calculate the third, right? Though often we solve it for C, and so you can rearrange this by taking the square root of both sides, and then I'm going to flip the 2 sides around. So C equals the square root of A squared plus B squared. Okay, now let's pretend that we graphed this triangle. I'm not going to try and draw the graph in underneath it. I'll show you that later just so you get the gist of it. But let's say that we know this point and this point. We'll call this point x1, y1 up here, and we'll call this point x2, y2. And we want to find the difference between, we want to find the distance of C, okay? We often will let that be equal to D for distance, right? Now, we don't know the lengths of these sides, we only know the points. But would you agree with me if we want to know side A, we can take this is y2 down here, right? And it doesn't matter which order you do this in, and I'll explain that in a minute. But we can take the difference between the 2 y's, oh, I'm sorry, those are subscripts. Okay, we take the difference between the 2 y's and we square it, and that will be the same as a squared, right? Because a is measured on the y-axis, and if we find the difference between those 2 points, that's the same as the length of side A. And again, it doesn't matter what order we do this in because we're going to square it. So negative numbers don't matter to us. It's fine. All right, now we need side B. B is down here on the x-axis, and again, if we take the difference between x2, which is right here, and x1, right, it's equal there, that will be the same side, so that will be the same length as side B. So it's x2 minus x1 squared, because we would square B, right? We're making something that looks like this, only we're doing it with the x's and y's. We said that we call it D for the distance, and we need to take the square root just because that's what we would do with Pythagorean. This, my friends, is what we call the distance formula. Yay! It's derived from Pythagorean Theorem. So if you ever get super confused about it and try to remember it, you can think of this, remembering that A measures the distance on the y-axis, M measures the distance on the, B measures the distance on the x-axis. And I was thinking about this, that's why I said M. Notice how this is y2 minus y1 over x2 minus x1. Notice that that pattern is the same in the distance formula. Huh, interesting, right? So that makes these 2 easy to memorize together because they look a lot alike. And one thing that's interesting about the distance formula is that we can arrange these x's and y's in lots of different ways. And I think, does John show us? No, well, you'll see John uses different versions, and I think it's in the advanced algebra book, he shows us like 4 different forms of this that all will work. I want you to memorize and always use this form because it is the easiest to remember, and it will keep your brain sorted out neatly as you try to keep these 2 formulas straight in your head. So now when we want to measure the distance between 2 points on a graph, we can just, let's just make an example. There's a graph. Here's 2 points that we want to measure the distance between. We simply, draw the triangle, use this point and this point in the distance formula, and that will tell us the length of that line. It's super useful, and it's going to come up quite a bit in other problems. So memorize this, but again, memorize it in conjunction with that one so that your brain will be happy. All right, let me show you what this looks like in a problem. There's just one problem, and then we'll move on to the lovely part B. Example 88.1. Use the distance formula to find the distance between 4 minus 2 and minus 5, 3. Okay, it doesn't matter which one we call the 1s or the 2s. I just do it in order, and we don't have to graph it. There's no need to graph it. So I'm just going to call them x1, y1, x2, y2. But please name the points, because otherwise it just gets too confusing. Okay, now we need to remember the formula. We remember it's something like Pythagorean, so I'm just going to write that one down to help me remember the distance formula. Oh yeah, the C turns into a D. We build the big old pig house. A is the change in the Y values, and we square it just like we square that. And then B equals the change in the X values. And these look like slope formulas, so I know I did it right. Okay, yay. This is just a great way to help you ease into this. It's kind of like Pythagorean Theorem and slope formula. Had a baby and named it the distance formula. Don't they sort of fit together nicely? So yeah, there's our distance formula. Now all we have to do is plug these numbers into this monstrous calculation and we'll be happy. Notice that I'm gonna do the usual. You know me and my buckets. I would rather take the extra precaution of using buckets so that I get the problem right than chance it and have to rework problems. I do not like to rework problems, you guys. I like to get them right the first time. It doesn't always happen, but I don't like to allow careless, silly mistakes to fall into my problems. I do make them from time to time. You've seen me. You know perfectly well that I'm all for dropping a minus sign, or I do ridiculous things too sometimes, but I really try to minimize that because I don't like to get problems wrong, because then you have to go back and redo them, and that takes time. And I've got other things to do, as do you. So please use buckets to make it easier on yourself. So what I'm going to do is I'm going to turn these parentheses into square-edged ones like so. And then I'm going to use little buckets in here for my values. And notice my values have minuses, so it's a really good idea to just put the buckets in. Anytime you have minuses in your formula and potential minuses in your inputs, you're asking for trouble if you don't use buckets. All right, I'm going in order. Y2 is 3. Y1 is minus 2. X2 is minus 5. And, oh, here I am. X1 is 4. And I think I just demonstrated to you how easy it is to get confused, because this calculation has a lot of drama in it. All right, 3 minus 2, that is 5 squared. Now that I'm reducing this, I'm going back to rounded parentheses for the whole thing, right? 3 plus 2 is 5 squared, plus minus 5 minus 4 is minus 9. Right? Now we'll actually do the squaring, and you'll see here now how it doesn't matter what order you put these points in, because you'll either get a positive or a negative value, and the negative goes away in the squaring process. 25 plus 81, and that means the distance equals 106. That's our final answer, and yes, we would reduce it if we could, but we noticed that 106 breaks down into 53 times 2, and 53 is prime. So we're done. That's our final answer. Please memorize the distance formula. Like I said, it's fairly easy because it's Pythagorean Theorem and slope formula had a baby. There it is. All right, let's move on to B, which has nothing to do with the distance formula or any of those other things. This is a physics topic. You guys have to promise me that someday you'll take physics and chemistry, because you're practicing so many calculations for it. This is a calculation, I think it's just from chemistry, yeah. All right. And chemistry does have a lot of mathematical calculations in it. If you haven't taken it, or if you have taken more of like a low level, like an intro to chemistry, you don't emphasize the calculations as much. You just talk about the cool things that happen in the world of chemicals. But higher level chemistry classes are always super math oriented. So what John does is introduces a lot of those calculations for you, so that you will feel comfortable with them once they show up in your chemistry class. Now, this is a whole lot of letters, isn't it? These all stand for something important. PV equals nRT. What John does is he very kindly gives you a list of what all those things mean in the book, page 366, so that we don't have to write them all down. You can put a Post-it flag on the page if that's helpful. And usually, look what he says here. We will not worry about the units. Bless his heart. The most important thing is we just need to know which numbers in the problem match up with which letters. And usually we can tell that because of the words John will give. But if there's any question, you can always look back to this little list. Using the relationship PV equals nRT, find the number of moles. Okay, which one's moles? Oh, that's N. N is the number of moles. Okay, so that tells us we're going to be solving for N. In an amount of gas, when the temperature is 273 kelvins, okay, that would be T. The pressure is 1 atmosphere, okay, that would be P. And the volume is 8 liters, okay, that would be V. And then this R is a constant that is always 0.0821. Luckily, John tells us that over and over and over again, so you don't have to memorize it. All right, so this is a fairly straightforward example of just taking the numbers in the problem and plugging them into the letters, again, using a little bit of help. But there's one thing that John suggests we do that I love. Before we start plugging in, I can't write today. As you saw, there are usually a lot of complicated numbers. So what we do is we rearrange the equation first for the one we're trying to solve for. In this problem, John said, use the relationship blah, blah, blah to find the number of moles. And when we looked at our checklist, or it's not really a checklist, the list, we found out that N is the one that is the number of moles. So what we do is we take the basic equation, which you're going to have to memorize that, Pivnert. We want to isolate the n, right? So we divide both sides by RT. That means, now I'm just rewriting it with the n on the left, PV over RT. That means we can use this for our particular problem, and then we just simplify. We don't have to do algebra with the crazy numbers, right? It's much easier to multiply by or divide by the letters than it would be to work out all the calculations. So this sets it up so that our calculation is easy. So we'll go n equals, and then we'll just make 2 buckets on top for the P and the V, 2 buckets on the bottom for the R and the T. Now we go back to the problem and plug in. I will read it. Use the relationship PV equals nRT, to find the number of moles. Yes, we're all set up. In an amount of gas, that's just the chemistry part. We can ignore it. When the temperature is 273 kelvins. Okay, there's temperature. We don't need to write the units in. The pressure is 1 atmosphere. That's pressure. And the volume is 8 liters. There's volume, 8. And then we remember, this R is the constant. It's 0.0821. Oh, that's so easy. And you know what? John does not even require us to calculate. If you would like to, you can. But this is what he considers to be the answer, and I am good with that, right? So what's hard in these? Number one, what's hard is you just have to remember to rearrange the equation for the variable you're trying to solve for. And number two, you have to be careful about figuring out where the numbers go because it's all these crazy words that we don't understand. But you can use that chart. It's just a list on page 366. If you feel desperate, right? And don't remember what anything is. Okay, that was example 88.2. And there's one more of these, and then we are done. The next one John wants us to work through, but you can use a calculator. So calculators are okay on this. All right, let's do the second example. It's 3 because we had the distance problem, but it's the second example of this type. All right, use the formula PV equals nRT, PivNert, to find the volume and then it starts going into the details. So right away, I know, we have to rearrange this for V, right? So that's easy. Just divide it that away. And then I'm gonna write over here, V equals nert P. Make sense? Okay, so now we're all set up. So now, before I read the rest of the problem, I'm gonna have 3 in the top and 1 in the bottom. Parentheses, buckets, always, always, always. They also mean multiplication, which is what we're doing here, so it makes things way easier. I suppose you technically don't need them on the bottom because it's just P by itself. But I strongly recommend that whenever you are adding numbers into a formula, just always use buckets. It'll prevent errors and save you so much time in the long run. The amount of time it takes to make the 2 little wonks is nothing. All right, 0.832 moles of a gas. Okay, N is the number of moles. So that means 0.832 goes here. If you like to put in a lead 0, that's fine. I often don't, doesn't matter as long as you're careful to notice that. That's why John often puts the 0, is just to draw attention to that decimal. All right, at a pressure of 3 atmospheres, pressure's on the bottom, such a big bucket, and a temperature of 400 K. And then it says at the end, R equals 0.0821. Oh, right, thank you. Okay, and there's everything just the way John likes it. Yes, this is correct. And then he says, and if a calculator is handy, we find the volume is V equals 9.11, and then we add back in the unit And I wouldn't know that the unit is liters, but if you look at that chart on 366 again, it says volume in liters. So I can use this to help me find the unit that I need for my problem, right? Atmospheres, liters, number of moles, temperature in kelvins, okay? So this can help you put the right word on your answer. But I'm also pretty happy with this. Yay! All right, that's the Pivnert expression. Whenever we're dealing with complicated formulas that have lots of variables, it always makes sense to solve for the one you're actually looking for so that then you can just plug in your answers. Guess what? That's all I have for you today. Just such a light dusting of algebraic knowledge into your life. Lesson 88 is complete. Go in peace. Goodbye.